Hello YouTubers! Today we have a very nice vintage radio on the bench, and we will check the sensitivity, because over a period of time, running every single day in my kitchen, the sensitivity is going down a little bit, and the volume is going down as well, so that might be connected to the sensitivity issue. And if such a radio is running really 365 days per year, then the tubes inside might be worn out a little bit, and that is what we have to check. And we will go through the schematic, and we will at least check the alignment to get this nice old radio back to nice work. Well, but let me say, these old radios are not only because you might like the look of it very interesting. So have you ever compared such an old vintage tube radio with a modern kitchen radio? And if so, you will certainly have recognized that the sound of this old tube radios is really awesome. It is really awesome. So, from that point of view, you have really two arguments for using it on a daily basis. It is design, it is the vintage look, which is nice, and on the other hand, you have really a nice sound. Okay, let's go step by step to see what we can do. Okay, I have now switched the radio on, and as you might know, it takes a while until the tubes are warmed up, and now it is working. But as you might recognize, this indication tube shows you that the signal strength is not really good, and so you can hear noise in the background as well. So that is what we want to check out. And the first what you can check when you work with such radios, you have to look for the power indication which it takes. So here you can see it should consume maximum 45 watt. And I have connected the radio to my service transformer. By the way, for safety reason, you should never open a radio or any electrical device without a service transformer. Connected to the service transformer, I have here a little watt indication, and what you can see, the radio is consuming 37 watt, and that is exactly what we can read here. So maximum should be 45 watt. So that means our first check is done, and it is in spec, so we can be sure that from that point of view everything is okay. Okay, so we must now go more in detail. Yeah, I mean, I really use this radio every single day, and for more than 6, 7, 8 years this radio is running with the same tubes. And the disadvantage of this old tube radios is that the tubes are worn out, and so that's the reason why I've already organized a nice set of new tubes which we can replace, and we will check the schematic, see what we do. We will measure the old tubes, and we will see whether we can find an old tube which is really down, so that that might be the reason for the bad reception. And yeah, on the other hand, we will double check the alignment, and then I have recognized that on this side there must be a little lamp faulty because it is dark, and here on the right side you might see that there is illumination in the back, and yeah, if you look here, it is missing. Okay, so let's open the radio and see what we find. So, back cover is taken away, and you can see the complete circuitry, and yeah, so that is really small, and to have a better overview and to be able to perform some more tests in detail, and as well the alignment afterwards, I will take the chassis out, and then we can look over the circuitry, and we can also have a look into the schematic and see what is what. And then next will be to check the tubes, and then we will have a first indication where we are. So I have taken the chassis out, and now you have a free look onto the circuitry, and yeah, you can find the tubes, you can find the rectifier and electrolytic capacity. So there is some material here on the top, so that might be an indication so that this electrolytic is drying out. I guess we have to check that. And this here are the band filters, and it is for FM and for AM, and yeah, you have here the different tubes, and I have here the schematic, and if we have a look into the schematic, we can see that here this is the FM front end with the FM triode and the FM oscillator and the IF stage 10.7 megahertz. And then we have the first IF amplifier, and we have here the band filters and the IF amplifier tube, and then we are here, we have a band filter in front of the IF amplifier, and we have it, it's a little bit difficult to watch through the camera and to see it here on the schematic, and here are the filters behind the IF amplifier. And then we have here the demodulation tube and the pre-stage for the final. So that is all integrated in here. So for FM and AM demodulation, and the preamplifier, the NF preamplifier is here as well. And then we have here the final tube, which is connected to the output transformer, and then here we have the loudspeaker. And we find it back here in our circuitry. This tube is the FM front end and the FM oscillator integrated in one tube. So that is the FM box, you can call it. And then here, so that is the first for the FM stage, it is the first IF amplifier, and for AM this is as well the oscillator tube and a mixer and so forth. So that is a multi-mode tube, you can call it. And here are the band filters you have seen in the on the schematic. So that is then the IF amplifier, and this here very next to the final tube for audio amplification. This is for demodulation and pre-amplifier for the final. And of course here you can see the loudspeaker, which is connected here right to this little transformer, and that is the audio output transformer, which is as you can see it here in the schematic, which is connected to the final tube. And you can see the loudspeaker connected to the audio transformer right here. Okay, so then next to do is checking the tubes step by step, and we might find a tube which is really down and needs to be replaced. So here is my tube tester, where we can check the tubes, and for any possible tube we have this cards where we can find the name of the tube. So this is a ECC85, which is equivalent to the 6AQ8. So that is more the American code, and this is the European code. So this is the front end tube for FM. FM, we call it here in Germany ultra short wave, which is the FM part, and the ECC 85 is the tube we have to check, and we have two cards for the ECC 85, simply due to the fact that we have two systems in one tube. So you can see it here. So that is one triode, and that is the second one. And as we need to check both, we simply need two cards. So that's the reason for these two cards. So it is so that is the reason why it is organized like this, and it is mentioned on here. So you can see triode, and it is card 1541 and 1547, and here on the side you can see it 541 and 547, and we start with the 541. You have to put it here on this connector field, and then we have to connect all these pins to connect anode and cathode and gate and the heater and what have we, to adjust everything that it fits to the tube. So then we have to take the tube out of the radio. So this is the ECC 85, and it is not readable anymore, but be sure it is the ECC 85. So now we put it here into the socket. Now it is in test position, and yeah, by the way, this old gear, you have really to take care about it to get nearly reliable reports out of this tube tester. First of all, in Germany in the past, so when this was produced in, I don't know, 1950, 51, 52, we had not more than 220 volts in on our supply, and these days we have 230. So that's the reason why I connect this to my service transformer as well, because then I can make sure that I have the 220 volt available in this tube tester, because if you supply a higher voltage, then you definitely get wrong measurements due to the fact that a lot of voltages which are supplied here all over are unregulated, and you really need the 220 volt and not 230 or even higher, due to the net movements. So you really need to make sure that it is 220. Secondly, inside this old tube tester are tubes as well, so rectifier tube and stabilization tube, and yeah, this is also very delicate, because these old tubes are on one hand very rare and therefore very expensive, and from my point of view they are not really reliable. So that's the reason why I put all the tubes which are inside this old tube testers out and replaced it with modern silicon diodes and what have you, so that everything is as much as possible reliable. And yeah, third, or last but not least, your old meter here. You know, the original one which are in here are also a reason for error reading. So they had a very bad quality, and so I replaced it with a new and modern one, and it was adjusted very carefully to this application, and now it is proved that what we read here on the scale is really what is available on the tube. So that is what you probe. You can really and reliably read on this meter. So that is just by the way, just to give you the information that it is very critical to use this old stuff, and I very often heard from radio friends that they are telling when they were around on a radio fair or whatever, and there was a dealer selling tube testers, and they had a tube and they put it in 5 different tube testers and always have different readings. Yeah, that is true, because you really need take care on this equipment to get a reliable reading, and therefore if you are interested to have for your workshop such a meter, a tube tester, you really have to make a proper maintenance to bring it in a condition that you can really need it as as a reliable meter. Otherwise, it is only advantage for collecting purposes, but not really for testing purposes. Okay, so let's start testing. So therefore we have to move this switch forward, and all these little steps are to check if there are shortages inside the tube. So if there is a shortage inside, then yeah, that is clear. I guess that a tube with internal shortage can't be used anymore. So that is what has to be checked first. And if there is a shortage, or even if there is a disconnection, so for instance, if I switch it now to the first step, this is checking the filament of the tube, and if the heater circuit, so the filament, is broken, you would see that this needle would go into the red zone, which is so that is information that there is a fault. I can show you how it looks like if I take it out. There is a disconnection of the filament circuit, and yeah, have a look on the needle. So I now take it out, and you can see it. It is really right in the left fault area, and that is a clear indication that on step 1 that if the tube would show it right now, then the filament is broken, and you can't use the tube anymore. So we have now to go step by step through all points, to all steps, and if on any step we see that the needle is going into the fault area, then we know we can't use it anymore. But I think that won't happen, because we have seen the radio working, and with a short circuit inside a tube, the radio wouldn't work. So that is definitely okay. So we are more interested in the emission of this system of the triode. So okay, but anyhow, let's go through step by step so we can move forward and forward. And as you can see, so there is no movement, so that means everything is okay. And now we go and check the emission of the system. And what you can see here, we are on the 25 milliamp scale, so that is the above scale here, and you can see three areas. So the left area here is that you have to replace it because the tube is bad. This area with a question mark is telling you might be working, but better replace, and everything above this line means the tube is good. And to double check it, I have here the indication for ECC 85, and that is telling me that it should have minimum 8 milliamps to be good. And having now a look onto my meter here, I can see the needle is here, so we are on the 25 milliamp scale. That means here is 5 milli, and in the middle 5 of 10 must be 7.5, and in the middle 7.5 and 10, which represents 2.5 milliamps, and 2.5 milliamps divided by 2 means 1.25 milliamps plus 7.5. So that is clearly over 8 milliamps, and that means we are in the good area. So this triode system is working. I mean, it is definitely not the best anymore, but it is you know, it is okay. Yeah, it is in the good area. Yeah, it is in the good area, and there is nothing mentioned that if it is just creeping into the good area, then that it is then bad. It only means good. So we can say, okay, it is okay. Now we have to check the second system in this tube, and therefore I have to prepare the second card. I have to take this away and put the 547 here into it, and check the second system here in the tube. So I have now changed the cards. Now we have the 547 here in place, and yeah, it's the same procedure. We have to go through all steps and see what happens. And so now I'm on the test position, and you see needle is moving, and as we know from the previously system, we minimum need 8 milliamps, and yeah, what we can see here is as we said before, in the middle 5 and 10 is 7.5, and this system is creeping very close to 10. It is not already 10, but almost. And as we have double checked, the minimum we need is 8 milliamps to have a good system. So yeah, we can say this tube is reasonable okay. So a complete new tube would have definitely a bit better performance, but anyhow, basically we can say it is good, and this tube does not need to be replaced. So yeah, let me check all the different tubes in here in the tube tester. I think it is very much boring if you have to watch all the single tubes. So I will go through it, and if I find a tube which is not okay, I will show you on the tube tester, but otherwise I think it is very boring if you see every single tube tested here in the tube tester. So at least one finding. Here in the test socket we have the EL84, which is equivalent to the 6BQ5, which is the AF final tube. And yeah, if we just measure it, yeah, I just switch through all steps, and yeah, we have to wait until it is heated up. You can see inside the glowing. Very nice. Okay, and yeah, here we have the value, which is, well, we are on the 100 milliamp scale, so that is scale in the middle, and that means we are below 20 milliamps. If we have a look here, we can see that we are here in the question mark area, and tendency to bad. To double check the value, the EL84 should at least have 27 milliamps. So we are almost reaching 20, but it is more, yeah, it is 18, whatever, so that doesn't matter, but it is clearly under 20, and that means this tube is nearly dead and needs to be replaced. But anyhow, this is the audio amplifier final tube. So that is an explanation for the lost volume. But it is not the explanation for the bad sensitivity. So yeah, that is definitely one point. We will replace this tube at least. But anyway, this is not the explanation for the bad sensitivity, and we have to look a little much more in detail what's going on in the circuit. So next to do is checking all the voltages which have to be available. Here is mains transformer, the rectifier, and here is the electrolytic capacity from the power supply, and we have to check first the voltage, which should be available here, and as we can see, it should be 253 volt. And yeah, let me check. So I just watched out for the measurement point, which is here. So that is plus, and plus of the rectifier, and this here is the electrolytic capacity. And I put my probe, right on here, and we're gonna check what we can find here. Yeah, so what we can see is we read 237 volt, 238, yeah, 238. So we should have 253. So yeah, I mean, not too bad, but it is definitely less than it should. And yeah, there should be a reason for. I mean, it could be that we have a leakage here on the capacity, that some current might go to ground. That could be, but on the other hand, we have still our 35 watt consumption power, and as it is mentioned here in the schematic as well, maximum reading should be 45, so we are fully in spec. Yeah, well, so that could be okay, because we should have in mind that when they made this measurements in the late 50s, they did not have our digital multimeter with a resistance of 10 megaohm inside, so they had analog meters with 50 kilo ohm per volt, so that is much less than what we have today. So from that perspective, it could be right that they measured a lower voltage than we do today. But anyhow, you remember when we opened the chassis, we recognized here on the capacity, on the electrolytic, that yeah, there is some grind on it, which may be electrolytic, which came out. So there is a good chance that this electrolytic is not in spec anymore. So I guess it's a good idea to take it out and check the capacitance value and the ESR resistance, just to make sure that this one is not the reason for our low voltage. So here's now the capacity under test, and it is it's a dual one, which yeah, so you can see it. It's a dual one, as it has been done these days. So it is 2 times 50 microfarad and a high voltage one, 350, 385 volt, and yeah, as expected, the reading is 30 microfarad, which is a bit low. So that is what I expected, due to the fact that on top yeah, we can see that it started to dry out, and that is the reason why the capacity is down, and the second capacity inside this box is 31.6. So yeah, for sure the capacity is not as it should. Yeah, I have nice new capacitors here with 350 volt and 100 microfarad. So when I put this one on, we clearly, yeah, it's a bit difficult. It's a bit difficult. So we clearly see the meter is reporting nearly 100 microfarad. So that is very close. And yeah, I have to think about it. I have as well, this one is 47, 350 volt, so that should be sufficient. This is, by the way, the high temperature type, the 105 degrees centigrade, which is definitely better than this one. This is only the low temperature type, and in this old tube radios we have a certain amount of temperature, so it might be good to put the 47 type into it, or better, two of those. But on the other hand, I think the 100 microfarad can do it a bit better, because yeah, it cleans the DC voltage out better. So yeah, so we have advantages and disadvantages, and yeah, I have to think about it. But maybe with the new capacitors we will have at least a bit higher voltage reading what we should. Okay, new capacitors are in, so you can see it right down there. So the old one is replaced, and yeah, I know. For all the radio collectors, and all the vintage fans, I know that is not a good idea to replace this nice old capacitor with these bloody modern things. But okay, but on the other hand, you know, we use it on a daily basis, and it is really better for safety reasons to have new capacitors in. I mean, yes, there is a regeneration procedure, how to bring up the lost capacities to an old one, and I'm gonna try it to refresh it. So I have the equipment to to start regeneration on it. But anyhow, for the moment, the new capacitors are fine. And okay, so switch on. Wrong one. This one, okay. So let us check. It's still heating up. It is okay. Let turn the volume down and let's check the voltage. So there is plus, which we have to probe. Oh, have a look. Have a look. 251. So that is very close to 253. So yeah, so that is, in my opinion, that is much better. And what I recognize, so this 50 Hertz broom on it, this net noise is gone, so it was much more available before the replacement. So in any case, so that is one side, which 250, and the other side is this with 214. We haven't checked it before, but anyhow, if this is a double pack, I have to replace both, so there is no way. But the net side right behind the rectifier is now very close to 250, and yeah, that is good. So let's prepare for leachment. So we have already looked here into the schematic. So here we have the 10.7 IF, and we have here all the different band filters. And on this plan we can find all the little filters which we have to adjust, and we start at the FM box, and yeah, remember what we have seen here. So we have here, it's a little difficult to see, but that is 111, and that is 112. Where is it? Here. And we find it back here. This is our FM box. So the FM box is here with our ECC, with our ECC 85, and one adjustment point. One adjustment point is right down here. And the second one is from the other side, which is this one here. So it is always from two sides. This I take it out, then we have less reflection. yeah, you can see it here. The 111 and the 112 is in one little tube, and we have to adjust this both pieces to adjust for best signal strength, and as well to meet the filter right in the middle. So, okay, before we can start, we have to prepare our mesh equipment. First of all, I have already put my this frequency sweep generator to 10.7 megahertz, which represents the intermediate frequency for FM, and the output is connected already to the tube, and as you can see it, I have just put a little wire around the tube, and I blow the signal right into the tube. So the tube is glass, and I blow the 10.7 megahertz right onto the tube, onto the glass, and so that will inject into the tube. So that is, as you can see, my input to hit the first stage, and that makes it possible to adjust this filters here. So that is a 10.7 megahertz first IF filter for FM radio. Okay, so I gonna sweep it, and therefore my sweep output, so this is a ramp generator which runs here right to my oscilloscope, and one input will be epsilon, and the other one, this one, will the x-axis. So this is connected. I have already the epsilon input connected to the board, so that is at the end of the circuitry, so that is the demodulation circuit, and especially I am here at the ratio electrolytic capacitor, so that is a point where we have to check. And yeah, I have already wired here these little wires to the PCB, and so that will be the epsilon axis to see at least the filter on the oscilloscope. Okay, I have to switch it to XY operation. So this is now I have to switch this to here. Now this is the epsilon, the X input. This is epsilon input, and I have to switch my gen to sweep, and now it is sweeping, and you can see already the X axis is already available, so that is very nice. And now I have to connect my radio back to mains and switch it on. Okay, now it is on, and now it takes a while until the tubes are warmed up. Look at this. So here is the filter response. I try to switch this light off, then it might be better to see a little bit. This is not good, so leave it like this. Yeah, what can we see? First of all, this here is the filter response, but not only of this filter. It is not only this filter, because I'm injecting, as I told you, the 10.7 megahertz right into the tube. I blow it on, and but I'm taking the signal here at the ratio electrolytic condensator, and that means it is the complete track which is in between. So this here represents the complete enrichment, right from the beginning up to the end. So that is the complete enrichment. And what we can see here is this here is a marker, and the marker should really be in the middle of the filter. So what does it mean? The enrichment is not really in the best position, because the filter is, or the marker is not in the middle, so that means that the filter is not on the right setting, and some frequencies are not able to pass through in the respected or expected way, and therefore we have to see if we are able to bring it back in the middle. And secondly, what we need to achieve is the high of the filter, because that represents at least the gain which can pass through. So it might be clear that frequencies out of the 10.7 will be attenuated, so maybe a frequency which would be at this point gets attenuated, and frequencies at this point are less attenuated. And now we try to bring this gain up, that the attenuation is even less than it is right now. So that will be next. So as said before, I have to move all the coils. So one is here, as I already said. Then FM is this, and where is it? This. So we have this and this for FM, and on the other side, so that is the back, we have this here and that. So that is what we have to do first, and just I'm gonna start here. Okay, just to try to get in. So, and now let's see what this can do. Yeah, what you see, I can move the filter, and I would say yeah, now it is a bit better in the middle, so that is as it was before. Now it is definitely better in the middle. So I try now the other side of this filter, and let's see what we can do. Yeah. So that change a bit, but not significant. So we try to use the next one, which is, where is it? Here, this one. And let's see what we can do here. Yeah, so we can get a bit more gain, which is good. And so that is what I have to try right now. I have to go through the complete filter set, back and forth and back and forth, and try to achieve a better setting of all the filters, and this will take a while, so it will be really boring to do it on the camera. I will let you know the result. I don't know whether we are able to increase it much more, but Epsilon setting, which is here, is now on, what is it, 0.5. Maybe we can achieve it. We will see if I can get much higher. Yeah, we will see it in the end, and I will report it to you. So, a bit more was possible. So marker is right in the middle, and the 3 dB points are plus minus 80 kilohertz, so that is great. And from that perspective it is a bit more, and enrichment is now okay. And now we have to enrich for linearity. That will be the next step. After all, there is still a problem inside the circuitry. So there is still distortion in the audio, and yeah, so there must be another issue as well, and presumably there might be something wrong with some additional capacitors. So as you can see here, this and that capacitor, which are couple C's for the final, are already replaced, I guess 5 years ago. So these are the most critical, because if they are not really okay, they bring positive voltage on the gate of the final, and that would really bring up problems. So this has already replaced. So in the schematic it is this C, because you know, without this coupled C, the supply voltage for this tube would directly go onto the gate of the final. And what we really need is a negative voltage on the gate, and that wouldn't be possible if this coupled C is not available. And yeah, on the other hand, in this old radios, this is very, very often a problem. And therefore, that is the first what you have to check. But as I told you, this C has been replaced 5 years ago. You see another one down here, so these are brand new. But there are still some old C's, like this and this. So that is for the tone, trebles and basses, and these are still old, and there is another one down here. This has already been replaced a couple of years ago. This is this where is it? This one. So this is important as well, that there is no leakage current. But this is already replaced, so no problem. And then another problem is always. Now let's go back to the schematic. So this again is a final, and here we have a capacity, the cathode capacitor, and this electrolytic capacity brings up problems as well. And this hasn't been replaced, so I have to check if everything is okay, because in combination with this resistor here, this is to bring the negative voltage to the gate, which is really important. So I have to check this, and I have to replace this capacitor, and there's another one down here. So that is the tone network, and yeah, so that is what we have to do next to prove that everything is perfect here. So we are now probing here at the cathode of the final, and the reading is 8.7 volt. So that is this point here, and the schematic is telling us that we should have 7.6. So 7.6 is what is expected, and we are probing no, 1 volt too much. So yeah, that is indication that something might be wrong, and we have to investigate it to make sure that this capacitor is okay. And I guess I'm gonna replace the old capacitors which we have seen here. So these are really old capacitors which are definitely leaking. So yeah, so that will be the next. So, after changing the capacities as described before, so now all the capacitors in the tone track are changed, and as well I have a new capacity in the cathode of the final. Yeah, the radio sounds quite nice. So, 'cause I got too much life running through my veins, going to waste. So finally, there is one point I really want to show you. I mentioned before that we have to allege for linearity, and within the ratio detector there is this coil where finally the audio frequency comes out, and this needs to be adjusted right in the 0 point, so for the positive and negative half waves. So this needs to be really in the middle, and therefore we need to allege it very carefully, that yeah, you have the best result. So therefore first I've connected the generator once again, and I put a tone on it. You can't hear the tone right now because there is a dummy resistor connected to it, and parallel to the dummy resistor, which represents the loudspeaker rights now, is here the voltmeter, and with the frequency adjustment I bring it at the highest value, and that is representing the most signal strength of the RF signal. So with it now adjusted to the maximum. You can also see it here on the indicator tube. I switch the NF off, so now we have only the carrier. without any tone, so you can see it here. So there is no signal, so no audio signal anymore. So there is no signal on the RF. And now I'm measuring. So my analog meter is positioned in the middle, so that we can get the indication for left and right, and we need to keep it in the middle, and therefore I connect the meter here between these both resistors, which are connected to in the ratio detector. Between this this A and B, I have soldered this both resistors with 220 kilo ohm each, and in the middle, and at the output of the filter. So once again, between A and B, this little resistor, and in the middle, and at the output of this little coil over here, we need to have exactly 0. And yeah, it is already connected. When I go into this filter, yeah, so you can see it. It's a little reflection, I think, so you can see it. Now I'm turning, and you can see I'm now walking outside the middle. So the other way, you see I'm moving in the wrong direction. So what we need is exactly the middle. So then it is adjust for linearity, and both sides of the wave have exactly the same distance to move, and yeah, so that is the 0-point adjustment, and yeah, that is a little bit delicate, but anyway, now I'm off the filter, and yeah, it is a little bit out, but so that is so less that it doesn't matter. Okay, to summarize, we found a dead tube, and we changed the net capacitors directly behind the rectifier, and we changed the capacities here in the tone section, and as well we changed the capacities, electrolyte capacitor in the cathode track of the final tube. We performed a complete leachment, and after all, the radio is now in a quite nice condition, so I can reassemble it, and yeah, I can hopefully use it for another 10 or whatever years, and yeah, so that will make fun, I'm sure. Tja, End of story. Old tube radio is working fine again. I hope for another couple of years, and hope that was a bit interesting for you. Okay, bye.